One final example that we have is going through another hypothesis test of one proportion. And this one reads that according to the Center for Disease Control and Prevention, the CDC, approximately 19% of all people worldwide wash their hands after using the restroom. Random observation of 200 independent Americans, 160 washed their hands after using the restroom. Is there evidence to suggest that the proportion of all Americans that wash their hands after using the restroom is higher than the worldwide parameter, tested at the 5% significance level? So, once again, we're going to go ahead and start by defining the null and the alternative hypothesis. So, we're going to say that the null hypothesis, we would assume that if 19% of all people worldwide wash their hands, then we would assume that of those 200 independent Americans, 19% of them would also wash their hands. So in other words, P equals mu sub P. The alternative, we look at the problem, and in the problem, it says is higher than. So using the restroom is higher than the worldwide parameter. So the key word there, higher than indicates greater than. So we're going to say P greater than mu sub P. Collecting the variables, the population proportion is 19% reported by the CDC. So mu sub P is 0.19. P is going to be equal to 160 out of 200. And if we type that in our calculator, that should be 0.8, which it is. The probability of failure Q, 1 minus P, is going to be 1 minus 0.8, which is 0.2. We know that the sample size is 200, and the significance level this time tests at the 5% significance. So alpha is going to be equal to 0.05. So that's step 2, collecting up the variables. Step 3 is going to be able to draw the distribution. The distribution is always predicated on the alternative hypothesis. We know that the alternative hypothesis is that P is greater than mu sub P. So that means it's going to be a right tail test. Range of values on the distribution is 0 to 1. We have a right tail test. The fail to reject region is clearly going to be the unshaded region. The reject region is going to be the shaded. And then remember, for a right tail test, we use 1 minus alpha as the cutoff, or 1 minus 0.05. In this case, the cutoff between the reject and the fail to reject region is 0.95. So 0.95 is this line right here that separates reject and fail to reject. Any p-value greater than 0.95 is going to be a reject. Anything less than 0.95 is a fail to reject. So how do we determine that? That's what we use the p-value for. Okay. So remember, to get the p-value, the first thing that we compute is sigma sub p, found by the formula pq divided by n under a radical. Remember that p is 0.8. Remember that q is 0.2, and that n is 200. And I got all those variables up top. So that's this right here, p, q, and n. I'm going to throw that into the computer, or to the calculator, excuse me, and I'm going to compute. So if we compute, I got 0.028 approximately. So our standard deviation, 0.028. Great. Now we're going to compute the actual p-value. Formula for the p-value, first we get the z-score. Remember, z is p minus mu sub p divided by sigma sub p. We're going to fill in the blanks. We know that p is 0.8. We know mu sub p is 0.19. And then we're going to divide that by 0.028. Now we're going to get a really big z-score this time. Okay, so in this case, z, remember we always round z to 2 decimal places, so we get 0.8 minus 0.19. We're going to divide that by 0.028, and I get 21.8. All right. Now we're going to go into the z distribution, or into the z table, and since z is greater than 3.9, we look down into the fine print. And remember, if the z value is bigger than 3.9, then what that means is that the p-value is approximately 1. Now technically, I think the table suggests that it's 1.0000. All right, we could just say 1 for this. Okay, so that's our p-value. We're going to plot that on the distribution. So we're going to go all the way back up top here, and we're going to plot the p-value. The p-value is 1. Okay, so p-value is going to be equal to 1. And this time we end up in the reject region. Okay, so now what we know is that we end up in the reject region, which means that we do have evidence to reject the null hypothesis. Okay, so let's type out our conclusion. Since the p-value falls in the reject region, we reject the null hypothesis. And so we have to answer the actual question. So we're going to go back up to the top. And the question was, is there evidence to suggest that the proportion of Americans that wash their hands after using the restroom is higher than the worldwide parameter? And to answer that question, we can say yes, there is evidence to suggest that the proportion of all Americans that wash their hands is higher than the worldwide parameter. We can say this because the p-value fell into the reject region. Okay, so anytime we have a yes, that's a direct function of the p-value is in the reject region. So p-value in the reject region. I want to rewrite that. So we have the p-value in the reject. Sorry, I had to go on to the next line there. All right. So this is essentially going to be the last part of section 14. So I would recommend that you go back, maybe work some of the homework problems, and then try to make sure that you're okay being able to do this before you move on to section 15, which is going to be hypothesis testing of two proportions.